Okay, so like I mentioned at the beginning of the last segment, what we're getting to is cosmology. What we're getting to is what can we tell about the universe, the whole big giant cosmos that we live in. And in order to be able to figure out what's going on with that, you have to understand light. You have to understand what it is and how it works, and a few different key, I don't know, qualities and characteristics that light has. And that's what we're going to get to on this, okay? So, light, what it turns out, what it really is, it's called electromagnetic radiation. Okay, I want you to say that word out loud just right now. Electromagnetic radiation. Again, if we were in the classroom, I'd make the whole class recite it. It helps you learn it. So please say it even though you're working at home. Electromagnetic radiation. Electromagnetic radiation. Okay, and without getting too much into what electromagnetism is, what's interesting, and this was the guy, Maxwell was the guy who discovered this, that electricity and magnetism are like flip sides of the same thing. It turns out instead of there being just an electrical force that you use in electrical devices and stuff, and there being magnetic force that you have in magnets attracting stuff, turns out it's kind of the same thing. It's called electromagnetism. That's why in seventh grade, when you guys made an electric motor, remember what happened when you wound that wire around the nail and turned into a magnet? Right? And that's how electric motors work, by creating a magnetic field that will turn the propeller or whatever it is, all right? Or an electric generator works by rotating that magnet, makes the electric current, because these things are flip sides of the same force. So electromagnetic radiation is when that electromagnetic force travels through space, okay? We call it light, all right? Now, go ahead and write this next one down here. Again, if it's yellow, you didn't have to write that one, but you do have to write this. What is light? That's the question, and here's the answer. Light is electromagnetic radiation. So write it down. If it's white, you gotta write. Now, here's the thing. It travels through space. Again, if you need more time, pause the video, write it down. But it travels through space in the form of electromagnetic waves. Waves, like a wave that travels over ocean. The visible light we see is only a small part of the electromagnetic spectrum. That's the thing. I mentioned in the last one that we see different colors. In our eyes, the back of the eyeball, there's something called the retina. It's like a layer on the back, and it has the light receptor cells. And when a certain wavelength of light hits that receptor cell, some of them are sensitive to red or green, and some are to blue or yellow, and it will activate it, and it will make that nerve, fire back to your back of your head, actually, fire into your brain and send a signal. I see red, I see yellow, and then the patterns get interpreted by the brain as, oh, I see I don't know, a beach scene or whatever it is you happen to be looking at. The visible light we see is only a small part of the electromagnetic spectrum. I'm going to get there in a minute. We got the red, orange, yellow, green, blue, indigo, violet, the 7 colors. But then there's something redder than red. And you can't see because you don't have receptor cells. It's called infrared. Or there's something like ultraviolet. It's like a super duper violet. Well, the wavelength is so small you can't see it. Our eyes don't have receptor cells, but they're very real and they're important to understand that. So let's go ahead and get into that electromagnetic spectrum. One thing about waves is you can have waves that have they're like long, really wide between them, like, or you can have some that are like, and distance, the length of the wave is the important part of it. How long that wave is from peak to peak. And there's a scientific name for the length of the wave. Can you guess what this might be? Can you guess what the scientific word for the length of a wave is? Wavelength. Okay, so that's an easy one. Finally, we got a science term that's an easy one. So please write this part down. Waves, okay? The different colors have a different wavelength, okay? The wavelength, I don't know if you've heard that term before. I hope you have. It's also known as frequency. You don't have to write the shorter or longer wavelength part here. But If it's got a longer wavelength, that would be a lower frequency. It would happen less frequently, right? It would be like boop, 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 boop. But it'd have a shorter wavelength like this. It'd be like boop, 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 boop. So that would be a higher frequency. Okay, so in light, you talk about frequency or wavelength, it's the same thing, except for it's kind of inverse because the longer the wavelength, the lower the frequency.